Hello everyone, please take out your books, pens, and pencils because it's another session of learning mathematics conceptually with Mrs. Bensley. Today, we will be looking at writing algebraic expressions. So by the end of this video, you should be able to write algebraic expressions from worded sentences and write worded sentences from algebraic expressions. Before we start, let's revise what algebraic expressions are. Now, these are one or a combination of terms and can consist of variables, constants, and or coefficients and variables. Usually, our algebraic expressions are separated by our operators. Let's look at one example. We have 5x plus 3. This is an expression. If we look carefully, we realize that we have a 5. This 5 is multiplying our x or our variable, and so it is known as our coefficient. Our x is our unknown, it is our variable. Our plus sign is our operator, and our 3 is our constant. In this algebraic expression, we have two terms. Our terms are 5x and 3. And they are separated by the operator, which is our plus sign. Now that we have revised what algebraic expressions are, we want to look at some of the terms that we use when we are writing algebraic expressions. The first one is to add. We talk about adding, we talk about plus, we can talk about the sum, we can talk about increase by, and we can talk about more than. Now, when we are writing our algebraic expressions, we are going to see these words in the sentences, and we are going to need to be able to realize that even though it says increase by, we're just adding. So all we need is a plus sign. Even though it says more than, we're just adding. All we need is a plus sign. All right, there are some important things that we need to recall. So let's quickly look at those. If we have 2 plus 5, it's the same thing as 5 plus 2. So 7 is equal to 7. This tells us that the order is not important when we're adding constants. In other words, addition is commutative. The same is true when we are working with our variables. The order is not important when we're adding variables. Therefore, x plus y is the same thing as y plus x. So overall, let us remember that addition is commutative. Let's look at our first example. This one says the sum of a number and 7. When we talk about a number, what are we talking about? So a number is referring to any number. We just do not know what this number is. And since we don't know what the number is, we're not able to put it in the sentence, or we're not able to solve the problem. For this purpose, we're going to need to use a variable to represent this unknown number that we're referring to. For this problem, we are going to use the variable n. So a number n. So let's reread the question. So therefore, it is the sum of n and 7. We know that sum is the answer that we get when we add two numbers. Therefore, this is the same thing as n plus 7. Let's try another example. Let's look at a number increased by 12. Increased by means the same thing as to add. And we're going to let our number be x. So we're going to add x plus 12. Let's see. Let's look at another example. A number more than 8. This example is a little bit more tricky because we're looking at a number that is more than 8. If we make our number c, so we let our number be the variable c, then we are going to get 8 plus c. Please remember that addition is commutative, so it doesn't matter if you write 8 plus c or c plus 8, the result will be the same. So I'm going to have you try this example. 13 plus a number. If you say the number is x, what would be your answer? Absolutely. So yes, it would be 13 plus x. So now I'm going to look at subtract. What are the words that we can use for subtract? Yes, we can use minus. The answer that we get from subtracting is the difference. So minus or subtract mean decrease by. The answer is going to be less than. We're talking about subtract or take away from. And of course, we can also use the word less. So these words are important for us to remember. Whenever we see the word decrease by, whenever we see less than, whenever we see less from, minus, take away, subtract, and of course difference, it means that we are going to subtract. All we are going to input in our algebraic expression is a minus sign. It's a subtraction sign. Before we get into it though, let's quickly revise. 5 minus 2 is 3. But 2 minus 5 is negative 3. This means that when we're subtracting, the order is important. This is because subtraction is not commutative. It's the same thing when we're dealing with our variables. X minus y is not the same thing, and there's an error here, as y minus x. So when we're solving problems with our variables and we're subtracting, we have to pay attention to the order of our numbers because subtraction is not commutative. So let's look at some example. The difference of a number and 7. So we're going to make our number be the variable n. Difference means that we're going to subtract. So we're finding the difference of a number and a 7. So we're going to write or a number first. So we have to write towards n first. So this becomes n minus 7. Let's try a second example. And you can always pause the video so that you can attempt the question before the answer is revealed. A number decreased by 12. We are going to let our number be the variable x. So this becomes a number x decreased by means to subtract or to minus 12. So we have x minus 12. All right. So you are going to try this example. It says 14 less a number. And we're going to use u to represent our number. Remember, we can use any variable of your choice. So if you got 14 minus u, you were correct. So since 14 appears first in our sentence, then we will have to write it first. Let's look at another example. Let's look at a number minus 81. And you're going to try this one on your own, and then you can check your answer. We're going to let our number be y. So what's a number y minus 81? Pretty much. It means the same thing as y minus 81. Now, this question says 14 less than a number. And we're going to use x to represent our number. Usually we say, let's just write the number that comes first. But for this problem, it's a little bit different. Why? Because 14 is smaller than the number, because it says 14 is less than a number. Therefore, when we have the word than in our sentences or less than, we are going to need to write our second number first. So we're going to write the last number first. And this is because of the than, the less than. So it becomes a number which is x minus 14. Let's look at a number from 23. And we're going to define our number as p. Again, this problem can be a little bit problematic because of the from. So we're going to need to really think about what the from means in this sentence. Say I go to the market from school. It means that our start point is school. So when we are writing our algebraic sentences or expressions, and we have the word from, it tells us the number that follows the from. It tells us where our starting point is. So we are always going to have to write the last number first. So we're going to start out with 23 and then write 23 minus p. So we're looking now at multiply. What are some words that comes to mind when we talk about multiply? So yes, we talk about double. We can talk about the product, which is the answer that we get after multiplying two numbers. We can look at a common one, which is times, or another common one, which is by. We can also use the word triple or twice. And these are all words that we're going to use in this video. So whenever we see words like this, it means to multiply. So we're going to use our multiplication sign to replace these words. Now, it's important to recall that there are many ways that we write our multiplication. 5 times 2 is the same thing as 5.2, which means to multiply, which is the same thing as 5 open bracket 2 close bracket, which means to multiply. So when you see two numbers separated by a bracket, it means that they're being multiplied. There's no other operation there, and it same holds true for when we have a constant and a variable, and we would say it's a coefficient because the coefficient multiplies the variable. So we can also use an asterisk to represent multiplication. So if we have 5 times y, it's the same thing as 5 dot y, or 5 open bracket y close bracket, or 5 asterisk y. All of this means the same thing as 5y, which is 5 times y. And we know 5y is the simplest way of representing 5 times y. If we look at 5 times y, however, with the multiplication sign between them, like in this example, yes, we know it reads 5 times y, but our times seems to resemble our multiplication. So it could be the same thing as 5 times x times y. For this purpose, we are going to need to be careful when we're writing our letters or our variables in comparison to our operators. So we usually use the italic to write our variables, or if we are writing them in our books, we'll write them in cursive. Let's look at 17 times a number. What does this mean? So we know times mean to multiply, and we're going to use n to represent our number. So this would be the same thing as 17 times n. And of course, there are many ways in which we can represent this multiplication. There are many ways to write a multiplication problem, but the simplest form is to say 17n. When we see 17n, we know that it means 17 times n. If we look at the product of 81 and a number, again, we are going to use y to represent our number, and again, it means 81 times y, or 81y, and the simplest form is 81y. We don't have a sign between them, but we know that it means that they're being multiplied. Let's look at a number by 71. By means to multiply, and if we use our number to be z, then we end up with z times 71, or z times 71 with a dot. But because the standard format of writing a number times a variable is to write the coefficient first and then write the variable beside it. So the more acceptable way of representing this would be 71z. And remember that multiplication is commutative. So it doesn't matter the order in which you write the numbers. If we write double a number, so we're going to double a number. If we allow our number to be y, then it's 2y. And we can always use our different representations of 2 times y. It doesn't matter which one you choose. It's always up to you in this situation. But of course, as we say, we try to eliminate writing the times sign or the multiplication sign because sometimes it can be mistaken for the variable x. And the simplest form, of course, is 2y. 2y without the bracket, the dots, or anything else. A number tripled. If we make our number z, can you write any representation, algebraic representation of this? What does it mean by a number tripled? And our number is z. So you are going to solve this problem and then we're going to look at it together. Yes, so triple means 3 times. So it's the same thing as z times 3 or 3 times z. And we know we can use the different representations. So our simplest form for our answer is 3z. So if you tried and you wrote any of these as your answer, you did well. You can go ahead and give yourself a clap. All right, let's look at one final one. Twice a number. What does twice a number mean? Let's make R our number. What do you think twice a number mean? All right, let's see. So twice means 2 times. So it would be 2 times R, or 2 open brackets R, 2 asterisk R, which is the same thing as 2R. Now, of course, they can add more words. There are other words that we can use to represent multiplication, but these are the basic words that are usually used. And to represent multiplication, there are multiple ways in which we can do it. Whichever way works for you, whichever way you prefer, you can always use that method. And always remember that there are many different ways to arrive at an answer in math, and so you always use the one that is most comfortable for you. Let's look at divide. The sign for division is this, and divide means the same thing as half. So you can say half of something means that you're going to split it up. Remember, the half is a fraction, and fractions mean the same thing as to divide. We can also use quotient, which is the answer that we get when we divide two numbers. We can use quarter, and we can use thirds. We can use just about any fraction because fractions mean the same thing as to divide. Is there anything important that we need to recall when we're dividing? Yes. So remember, there are many ways in which we can represent our division. Earlier we said that fractions mean the same thing as to divide. So if we have 5 divided by 2, it's the same thing as our fraction 5 halves, because fraction represents divisions. Likewise, if we have 5 divided by 2, it's the same thing as 5 halves. And if you don't have the applications to write the fractions the proper way, we use this slash to represent our fractions as well. And it also represents division. All right, so let's look at some worked examples. 23 divided by a number. And we're going to use P to represent our number. So what do you think our answer is going to be? That's correct. So it's going to be 23 divided by P, because we say 23 divided by a number. I can also be written as 23 with a denominator of P. If we have half a number and we let x be our number, then we can have x halves or x divided by half. for the quotient of 4 and a number, of course, quotient means to divide, and our variable is going to be represented with p. So it's 4 divided by p, and we can use any representation we prefer. How about the quotient of a number and 6? In this example, a number comes first, so we're going to represent it first, and we're going to use r to represent the number, and so it's going to be r divided by 6. So this really sums up or writing algebraic sentences or algebraic expressions when we have only one operation. But we're going to look at some multiple step examples. So these examples are going to include multiple operations. So we have 2 times a number plus 3. Now remember, order of operation, it's very important when we do questions with multiple operations. So we are going to need to ensure that we do the 2 times a number first because it comes first. So we do 2n, and for this example, we're going to let n be our number. So we're going to have 2 times n, then we add the 3. We can always go ahead and simplify. 2 times n is the same thing as 2n, so we end up with 2n plus 3. How about the sum of a number and a 7, then multiplied by 4? You can go ahead and try this one. So if you need more time, you can always pause the video. Alright, so n plus 7, since we're talking about sum, and we go ahead and multiply this by 4. Of course, this is not the simplest way in which we represent this problem. So we go ahead and write the 4, open bracket, n plus 7. It's the same thing as the sum of a number n and a 7, then multiplied by 4. Because if we're going to solve this problem, we have to work what's in the bracket first. A number tripled increased by 6. What does a number tripled mean? If our number is n, tripled means that it's multiplied by 3. So this would become 3 times n, and increased by means to plus. So we're going to add 6 to it. So it's become 3 times n plus 6. And of course, we have to use our simplest form to represent our algebraic terms. So 3 times n is the same thing as 3n, and we add our 5. How about the sum of a number and a 7, then multiplied by 4? I think we had this one before, so it remains the same. So we add the numbers, then we multiply it by 4, and we know we put the 4 outside of brackets, and we put the n plus 7 within the brackets. And when we have a number or 2 numbers separated by a bracket without a sign, we know that it means to multiply. I'm going to allow you to try this example. It says half a number squared, then add the product of 3 and another number y. How would you solve this problem? Yes, we're going to break it up into parts. So half a number n is the same thing as half n, it's half a number n squared. So it's half n squared, then add, so we're going to plus. The product means to multiply 3 times y. And of course, we can simplify this as n squared halves plus 3y. How about this one? The quotient of a number m and 3 less than 7. Alright, so I'm going to go ahead and identify the less than 7 first, because remember we said that whenever we are solving problems and we see less than, once we see the than, it means that we're going to write that part first. So I'm going to go ahead and write my 7. Quotient means that we are going to divide a number, and our number is going to be m, and we're going to divide m by 3. So I think this means 7 minus m divided by 3. And our simplest form is 7 minus m divided by 3. Now that we have done, or we're finished looking at writing algebraic expressions, algebraic expressions from worded sentences, we're going to look at writing algebraic expressions in worded sentences. So we're going to do the reverse of what we have been doing. All right, let's look at this. Now there are many ways we can write this. As we can start out by saying, this is 7 minus a number. We can also use a number from 7. So we write the last part first. And we can also say it's the same thing as the difference between 7 and a number. So when we are expected to write the worded sentence, it's left up to our interpretation. And of course, there are many different ways of representing them. So there's no one way to get to our answer. So if you have a friend who gets something different, once it reads the same thing, it would be correct. Let's look at 2y plus 5. So as we said, it can be twice a number, then add 5, because 2 times mean twice or double a number plus 5. Or it can be 5 more than twice a number, or 2 times a number plus 5. How about this example? So to solve this one, we need to ask ourselves, what needs to be done first? What should we do first? So yes, so this says we can have, this can be read as 82 minus n, then divide by 2. Or 82 minus a number, then divide by 2, sorry. But our number would be n. Or it could be half the difference of 82 and a number. And we can also say subtract a number from 82, then divide by 2. So remember, whichever method or whichever way you read the problem, once the answer remains the same, then you can go ahead. Because remember, we were looking at it first earlier, we said that when we see less than, less, decrease by, minus, difference, it means take away or subtract. So if we are going to read this sentence, then we can read the same minus sign as difference, decrease by, less than, etc. So this brings us to the end of this video. I hope that you would have enjoyed this lesson, that you would have learned how to write algebraic expressions from worded sentences and how to write worded sentences from algebraic expressions. I trust that the content learned would have been beneficial to you. And so until our next video, have a wonderful day. Bye.